In this video, we are going to learn about refraction of light at plane surfaces. For that, we are going to solve this problem. A light ray is incident on air-liquid interface at 45 degrees and is refracted at 30 degrees. What is the refractive index of the liquid? For what angle of incidence will the angle between reflected ray and refracted ray be 90 degrees? Now, let us first understand what is refraction. I am drawing a line here. This line is an interface of air and liquid. So, this is rarer medium and this is denser medium. Now I am drawing a normal line. This is the ray where the angle of incidence is I, which is equal to 45 degrees, and the angle of refraction is R is equal to 30 degrees. This is what is given in the problem. They have asked us to find out the refractive index of this liquid. So, how will you find the refractive index of this liquid? It can be found by using the formula refractive index is equal to sin I by sin R. So you know the value of I and you know the value of R. I am substituting those values and I will be getting sin 45 degrees by sin 30 degrees. Sin 45 is 1 by root 2 and sin 30 is 1 by 2. So I will be getting 1 by root 2 by 1 by 2, which is equal to 2 by root 2, which is equal to root 2. So the value of root 2 is 1.414. So the refractive index of the liquid is 1.414. Now let us see the second part of the question. At what angle of incidence will the angle between reflected ray and refracted ray be 90 degrees? So, the reflected ray will be in this way. This is the reflected ray and this is refracted ray. Angle between these two should be 90 degrees. What are we required to do? We'll write this as reflection angle. Let it be x. So, x plus r plus 90 degrees is equal to, since this is a straight line, this whole angle will be 180 degrees. We know that angle of incidence is equal to angle of reflection for smooth surfaces. This will be nearly equal. So, instead of x, I can write as I. I plus R is equal to 180 minus 90 degrees, which is equal to 90 degrees. If this condition satisfies, then you will get an angle of 90 degrees between reflected ray and refracted ray. We have to find the value of I, for which we will get I plus R is equal to 90 degrees. How will we find this? For this, we have to use this formula. We know the refractive index of this liquid. So, I'll write as 1.414 is equal to, we have to find the angle of incidence I such that the refracted ray and the reflected ray have 90 degrees in between them. Now, sin R. Instead of R, for this condition, you should apply I plus R is equal to 90 degrees. That means R is equal to 90 minus I. Okay. So, I will be using this here. Instead of R, I am writing 90 minus I. So, we know that sine of 90 minus theta is cos theta. So, sin I by cos I is equal to 1.414. I should get I from this equation such that both of the angle between both reflected ray and refracted ray is 90 degrees. Sin theta by cos theta is tan theta. So, tan I is equal to 1.414. So, I is equal to tan inverse of 1.414. In logbooks, you have tan inverse tables. From that, you will be getting the value as 54.7 degrees. That means the angle of incidence, if it is 54.7 degrees, the angle between the angle of, if the angle of incidence is 54.7 degrees, the angle between reflected ray and refracted ray will be 90 degrees. In the next video, we will solve more problems related to refraction.